Hi everyone, I'm Katie from Hackster. Welcome to the Develop a Wireless Remote Controller with Nrf Connect for VS Code webinar with Nordic Semiconductor. We've got Torbjorn Overbeck and Bjorn Kola here with us today to share more about the Nrf Connect for VS Code and how you can build a wireless remote controller using the Nrf 52840 DK and Nrf 52840 dongle. So a little bit about our presenters today. Torbjorn is a team lead in technical support at Nordic. He has a Master of Science degree in electrical engineering from NTNU in Trondheim and has worked for Nordic since 2008. While at Nordic, Torbjorn has been working as an application engineer in the support group and also spent 2 years in the US working as a field application engineer with the American sales team. He spends his time at Nordic doing demo development, software debugging, customer support, and much more. Bjorn is a product marketing engineer at Nordic. He has a Master of Science degree in engineering, cybernetics, and robotics from the Norwegian University of Science and Technology. So in addition to his 2 years in product marketing, he also has 2 years of experience working in tech support group at Nordic, focusing mostly on software-related support cases with a major focus on Bluetooth mesh and cellular IoT. In his free time, he enjoys playing tennis and biking. So a little bit about today's webinar. The first part of today's webinar will include a presentation and demo, which will be followed by about 10 minutes of live Q&A. So if you have questions during the presentation, there's a Q&A panel at the bottom of your screen. Please use that to type in your questions, and our presenters will answer as many questions as possible before the end of the webinar. Also, as a bonus, Nordic is giving away an Nrf 52840 DK and dongle to 3 webinar participants. So anyone who attends this event live with us today will get their name in the drawing to win, and winners will receive an email next week with more information on how to claim that prize. So thanks again for joining us today, and I'm going to let Bjorn get us started.
Okay, great. Thank you, Katie, for that great introduction. Just to put some faces to our names, my name is Bjorn Kola. I'm a product marketing engineer, and with me I have Torbjorn Overbeck. So I'll be doing just a short intro to Nrf Connect Sdk and Nrf Connect for VS Code. I'll also do a quick getting started with Nrf Connect for VS Code, and then I'll hand over to Torbjorn for the hands-on part for project configuration, how to add modules and functionality from different examples in Nrf Connect Sdk, and also debugging. And then at the end, we'll have a Q&A. I see we already have quite a few messages in the chat and Q&A, so that's great. And we hope to answer as many questions as we can at the end. Just quickly on communities, we do have a lot of different webinars, so technology intros and trainings. If you go to nordicsemi.com/webinars, you can register for any upcoming webinars. You can also watch on-demand webinars. So we do have, a lot more information on, let's say, Nrf Connect Sdk, for example. So be sure to head over there. We also have Nordic Developer Zone. So it's our tech support center and also online community. Last I checked, we had over 80,000 different posts in the Q&A section. So if your question was not answered during the webinar, you just feel free to head over to Nordic Dev Zone and get your answer, get your question answered there by one of our 30 to 40 plus engineers that man the portal. And last but not least, we also have Nordic GitHub, where we have a bunch of different repositories with code in it. That's at github.com/Nordic Semiconductor. Okay, so before we get started, I just want to run a quick poll just to see. So you should see a poll pop up now. So please, if you can just we'll take a minute or so maybe. If you can just answer some of those questions. Be interesting to see. Okay, quite a lot of answers popping in already. So that is good. Yeah, I'll just give it another 10-20 seconds. And it's good to see that most people are actually quite either have limited experience or moderately experienced. So that's good to see. Okay, so we're at 80% now. I think I will, I'll end the poll and then I'll share the results. So you should actually be seeing the results now. So the first one, are you familiar with Nordic Semiconductor and our products? So it's good to see that 46% of you are moderately familiar. That is good. The next question, how much experience do you have with Nordic Semiconductor development kits? So most of you limited experience, a few moderate, and around 9% are experienced. So we'll try to take this into account when we show the demo section and also when I do my presentation. How much experience do you have with Nrf Connect Sdk? So 39% said limited, 38% none. A few are moderately experienced. Okay, so that is good to know. And how much experience do you have with the VS Code ID? So that's good to see that 41% do have moderate experience with the VS Code ID. Okay, great. Thank you so much for answering that. I think that will help us during this presentation. We'll try to tailor our presentation and demo a bit to that. Okay, so just a quick intro to Nrf Connect Sdk. I don't have a lot of time, so it's going to be a bit high level. It is one code base and tool chain for our Nrf 91, Nrf 53, Nrf 52, and Nrf 21 series. The Nrf 91 series is our cellular IoT series. So that's where we have support for LTM, narrowband IoT, and GPS. The Nrf 52 and Nrf 53 series, there we have support for short range protocols. So that can include, Bluetooth Low Energy, Bluetooth Mesh, Thread, Zigbee, Matter, ESP, etc. And it doesn't mean that it's limited to those protocols, but just check our documentation for more information there. And the Nrf 21 series, that's our RF front-end module for 2.4 gigahertz range extension. I mentioned most of these protocols already, and we also do have a Bluetooth version 5.2 qualified host and controller stack since version 141 of the Nrf Connect Sdk. Just quickly on the code base, it does contain the application code, connectivity protocols, wireless stacks, and also peripheral drivers. So the code is organized into several repositories, and that is both Nordic and open source code. Here on the figure on the right, you can see the Nordic code is in blue, and the open source code is in purple. And even though we do have Nordic code here, it does most of the code available in Nrf Connect Sdk does use very permissive licenses, which means you can easily use most of the code in your end projects, without having to pay a licensing fee, for example. So we do have multiple repositories in Nrf Connect Sdk, and this does create a nice, code separation. So we do, for example, use the Zephyr repository, but we sort of make our own clone of the Zephyr repository, which means that if there were to be some kind of breaking changes in the code in the Zephyr repository, our clone of the Zephyr repository would not see that. So it's very useful to have multiple repositories, especially when working with open source code. I can go quickly through some of the layers. So board configuration, that would be mainly GPIO pin mapping, how to set up the different hardware of the boards. You have the Zephyr real-time operating system. So this is an embedded operating system run by the Linux Foundation. So it is designed for embedded chips. We have wireless stacks and peripheral drivers. So this can include things like, the lower layers of the Bluetooth stack. It include the L1 to L3 layers on the LT stack. Middleware, this can be your own code, for example. It could be the Bluetooth host implementation, etc., UDP, TCP. On the connectivity protocols, I mentioned that on the earlier slide. And then we also have the Nordic Applications. That's where we have a lot of applications and samples with good documentation. And the point of that is to make it sort of easier for customers to get started with the Nrf Connect SDK, so you don't have to start from scratch. And I'm pretty sure that Torbjörn, he started from one of those, one of the samples available in Nrf Connect SDK when making this demo. So moving on to Nrf Connect for VS Code, it is built from the ground up for Nrf Connect SDK. It's a modern, easy to use IDE. Yeah, most of you are familiar with VS Code, so it is basically our own extension to VS Code. It is highly extendable and configurable, so you can customize it to suit your needs. We do have both command line interface and also a GUI interface, all in one place, all in one window, which is quite useful. We also have a create new board wizard. So if you want to base it on one of the boards that are already available, you can basically update the device tree settings to a new board if you want to do that. And we do have a rich set of tutorial videos for getting started too. And we do have cross-platform support for the major operating systems. We do also support Sega Embedded Studio Nordic Edition, and this also does have cross-platform support. But I think if you're just getting started, and that's what we noticed from the polls too, that some of you are just, you haven't heard of Nordic that much, I would definitely recommend getting started with Nrf Connect for VS Code. That's also where, any future changes we'll put into Nrf Connect for VS Code primarily. We do still support Sega Embedded Studio, so it is still a valid option if you want to use that ID. But yeah, the recommendation is to use Nrf Connect for VS Code. You can use any other IDE with Nrf Connect SDK if you want to, but you won't have Nrf Connect SDK or toolchain integration. So just be aware of that. So if you want to recreate the demo, which Torbjörn will go through, there is a step-by-step guide shown on the webinar registration page. You need the hardware, so either the Nrf 52A40DK or Nrf 5340DK for the remote, and an Nrf 52A40 dongle for the receiver. Then you basically just download Nrf command line tools, Nrf Connect for desktop, open up the toolchain manager application, and then if you watch videos 1 to 4 from that YouTube playlist, you basically set up both Nrf Connect SDK and Nrf Connect for VS Code. And then you can just clone the shortcut remote demo code and you're basically up and running. And even for someone like me that's not a super amazing programmer, I actually got this to work in the first try. So that's it's quite an easy getting started experience. If you do want to learn more, I can actually just quickly show a few more things that might be interesting. So we do have this Nrf Connect for VS Code product page. Oh, and one thing to note, we will share the presentation as a PDF. So you can easily just, look at these URLs that I've provided afterwards. So here we have the Nrf Connect for VS Code product page. You have a bit of information about it. You also have a very good webinar for introducing Nrf Connect for VS Code. And this is not like your very theoretical webinar. It does go quite into the code itself and how to get set up and get started. We also have these video tutorials, which I mentioned. So that helps with installation. It shows you how to create an application, how to build an application, also how to flash to a board, debug, if you want to migrate from other IDs to VS Code, and a few tips and tricks too. So that can be useful to look at. We also have this Nrf Connect Sdk product page. So here, again, the getting started experience is quite similar, but if you want to watch some of our webinars that go into a bit more detail on the Nrf Connect SDK, this is a good page to look at too. We do have an exciting new features in Nrf Connect Sdk version 1.8. Webinars, if you want to get a quick intro there, you can watch the first 15 minutes of that. We will actually, if you go to nordicsemi.com/webinars, we do have this Thursday, we do have the latest tag, which is version 1.9. That just came out. So if you want to learn a bit more about the newest features, just head over to nordicsemi.com/webinars. You can register for that. And last but not least, we also have developing Bluetooth low energy products with Nrf Connect Sdk. So this is a very nice webinar that, again, goes through how to actually program, how to actually develop products using Bluetooth low energy, Nrf Connect Sdk, and also Nrf Connect for VS Code. So yeah, I think that was basically the end of my part. So again, if you want to register for upcoming webinars, just go to nordicsemi.com/webinars. And I think without further ado, I will hand it over to Torbjørn.
Thank you, Bjørn. Can you hear me?
Yep.
I will share my screen then. I think you can see my screen now.
Yep.
Good. So today I will basically walk you through the demo that Bjørn has mentioned briefly. I'll start by just a couple of quick slides showing what we're trying to do here. So essentially the goal with this demo was to make a shortcut remote control. It can be used to send various shortcuts and hotkeys to a PC. And the way we're doing that is that we're using one kit. You can see the kit on the right, where you can press buttons. All the kits come with 4 buttons by default, and we'll use those 4 buttons to send 4 different commands. Then it will send a signal over Bluetooth, which will be received by a dongle. Here it will be converted to a HID report, which is then sent over USB to the PC. And the reason we're doing this is to be able to support any PC, even one that doesn't have native Bluetooth support. It's also a good way to show how we can combine many different examples into one. In this case, the USB HID examples and the Bluetooth examples used for this demo. And in total, I'm going to be sort of shamelessly copying code from 4 different examples in the Nrf and Sniffer repositories. So I'm going to use peripheral and central Uart examples. So these are examples showing how to set up a proprietary Bluetooth service, which is the one called the Nordic Uart service, which you might be familiar with if you've been playing around with the Nordic Bluetooth examples before. I'm also going to use a peripheral HID server keyboard example, which is an example showing how you can set up a keyboard style HID report. And then I'm also going to be using a USB HID example on the dongle side in order to send the HID commands over the USB interface. And for the development purpose itself, I'm not going to use a dongle on the dongle side. And the reason for that is that developing on the dongle is not recommended. The dongle does not come with a built-in debugger, which means that you either have to use a bootloader or you have to connect an external kit to flash the device. Logging is very tricky to get because you don't have the same logging interfaces like you do on the DK. So I strongly recommend using a development kit whenever you want to do development, even though you're targeting a different board in the end. And the same goes if you want to make your own prototype board. Typically, you start with the development kit and connect all your sensors and other hardware to the development kit, and then later on, you start targeting your actual board once that gets ready. So in order to sort of split all this into concrete steps, I've divided it into 14 steps in total, and I'm going to try to briefly go through all of these steps with you in the code afterwards. The first step is to simply set up a Git repository with a README and a Git ignore file, which is something I do out of habit whenever I start a new example. A README is obviously useful, and a Git ignore is also very useful because it prevents any kind of build files and other things to make it into your Git repository. Then I'm going to start on the dongle side, or the receiver project. I'm going to base this off of the USB HID example, and step 2 is basically just copying the entire USB HID example into my repository and using that as a basis. For this, I'm going to briefly showcase some of the HID functionality, and I'm also going to show some of the Sniffer kernel structures that I'm going to be using, which is Sniffer timers and also work items. Step 3 is then to take all the HID configuration from the main file and make it into a separate file. And the reason I do this is I like to have all the functionality split into separate files. So all the USB HID stuff will be in one CNH file, the Bluetooth stuff would be in a separate file, and so on. And then the application main file will simply be initializing and getting events from these different sub modules. Step 4 will be to change the HID descriptor, because the one in the USB HID example is very simple. So I'm going to make it a bit more complex in order to handle almost any kind of keyboard remote command. Then in step 5, I'm going to change the way that the HID packets are sent. I'm going to replace the original timer implementation with threads. Then in step 6, I'm going to make a small API for sending HID packets. And I'm also going to show how to use a message queue. I'm going to talk a bit more later about why this is important. And then in step 7, I'm going to enable local buttons on the receiver to send commands. And the reason I do that is that when you're debugging these kind of wireless applications, it's very helpful to try to simplify every step of the process. So for instance, to debug how I send commands over USB HID, I don't want to be reliant on having a working Bluetooth link. So for that reason, I set up buttons on the kit itself. And by doing this, I'm able to send commands directly from the receiver kit without relying on the Bluetooth connection. Then on step 8, I will set up the central Uart functionality in my dongle project. So once again, I'll just copy the entirety of an existing sample, which is the one called central Uart, which has a Uart client, which is sort of the, you can say, the scanner in the Bluetooth network, which can connect to the peripheral. Then I will create a random 128-bit UID, and then I will make the remote project in step 9. So the remote project will be the peripheral Uart example, which will integrate nicely with the central Uart example I already put into the receiver. Then in step 10, I'll simply copy the 128-bit UID that I created in step 8. I'll talk more about this later when I show you the code. Then in step 11, I'll remove all the unneeded functionality from the remote project, which was inherited from the peripheral Uart example. So there's some functionality there I don't need. And then in step 12 and 13, I will essentially set up button presses on the remote board, so that when I click buttons, this will be forwarded to the other side. And then in step 14, I will make the final connection between the incoming Bluetooth packets and the USB HID send packet functions, which allows me to forward all the functions from the remote to the PC over USB. So in order to show this, I will be using VS Code, obviously. First, I would like to briefly showcase the Nrf Connect for desktop, which is basically the sort of app store for Nordic applications. In here, we have something called Toolchain Manager. And on the Windows and Mac platforms, this is a very easy way to get started with the Nrf Connect Sdk and with VS Code. So essentially, with one click, you can install one of the SDK versions. And then with the second click, you can open the VS Code itself. On Linux, there's a bit more work. You have to follow some more manual steps to install the various tools. But VS Code and the extensions work fine on Linux as well. And all the build systems and everything else obviously also works great. So the only problem there is that it's a bit more manual installation to get started. So first, to get started with this, as I mentioned on step, I guess it's step 1 or 2, I basically want to copy an existing sample and use this as a basis for my project. And obviously, anytime you can copy an existing example, it saves you a lot of work. And when it comes to development in open source projects, so the more you copy, the better. There are some different ways to do that. In this case, I have the Nrf Connect plugins installed. If I go to my extensions, I can see that I have all these Nrf Connect plugins installed for me already. If you're using the Nrf Toolchain Manager, this will basically be handled for you automatically. A new feature that we got in one of the recent versions of the plugin is that you can now actually put the plugin itself and all its interfaces on the right side of the screen. So that means I can have all my folder views or debugging views and everything else on the left like you used to. And then you can have on the right side of the screen, you can have your Nrf Connect functionalities available here. In this case, I want to show how you can create a new application from a sample. I'm going to take the freestanding example in this case. I have to make sure that I'm using the right NCS version. This is a 180, which I'm using. I will pick whatever folder I want to use for my, let's try to hide this. I think this is okay. And then I can select an existing example and use as a basis. When I'm doing this, I basically can search through all the samples available, both in the Nrf and the Zephyr repositories. And there's quite a lot of samples available. So using this feature is a quite nice way to get an overview of what you have. You can also filter on things. So if you're interested in Bluetooth, you can filter on all the Bluetooth examples. In this case, I'm interested in USB. You know that USB can be found under subsystems. If I click on USB down here, I'll then immediately get all the USB examples. When you click an example, you'll see the README file immediately, which gives you information about what the example is doing and what functionalities you can find within. So I'll take a USB HID in this case, create the application. Then I'll immediately get to my main file of the sample. I can see the application here in the application overview. And from here on, I can create a board or a build configuration. In this case, I'm basing all my development on the 840 development kit, so I'm going to use that. And then click on build. When you do build, it's going to run through a full sort of project configuration and build phase, which can be a bit slow. One tip if you're running on Windows is to disable automatic virus detection on the folder where you store NCS. I just tested this today and found it to speed up the build process quite a lot. On Linux, on Mac, this is typically faster, at least if you compare it to a Windows installation with this virus detection installed.
Hi, Torbjørn. Is it possible to zoom in a little bit on the IDE area?
Yeah, I can try. See if I can try to make the screen larger.
If not, it's not a huge.
No, I think it's hard because there's so many elements to show, so I think it's going to be a bit challenging.
Yeah, totally.
So we are going to record video for this as well. So if it's hard to see all the details, you can come back to the video later and sort of zoom in on that. So I would urge you to do that. So this is just a standard HID example. Now that I have it open, it can basically go through all the different files here on the application overview. On the source files, I can check my main file here. Input file shows you the CMake list and the project configuration files, which basically sets up the build system and which software modules you're using. If you want, you can take a look at the hardware configuration in the device tree. So this is basically showing an overview of all the various hardware features on the selected board. And down here on the actions folder, we can see the various actions such as build and flash. Down here, I can see my connected devices. So right now I have two 52840 Sdks available, one that I want to use for the receiver and one that I want to use for the remote. So there's also a useful feature here. You can actually name your boards. So in this case, I know that the one corresponding to 803 is my dongle board. So I'll give that a more human readable name in order to make it easier for me to identify these boards later. And then a very useful feature is that you can associate different builds with different boards. So in this case, I know that this is going to be the dongle receiving device. I can associate that build with that board. And then whenever I click flash, it will automatically flash the right board. It seems I have a small sort of live bug here now. So I just have to start Visual Studio Code again. Sorry about that. So there are some occasional bugs when running the VS Code interface. Most of them can be solved by starting the application again. So I'll just double check. I have my application here, and I will try to flash it to my board. You can see it is erasing the existing flash content. And if you can see my log output here, you can see that this device is starting. And then I want to go to the next step, which is basically to integrate this code with the example. As I mentioned earlier, I want to sort of modularize the various functionalities in my example. So the way I do that with the HID example is that I make my own module. If you can look down here. I'll put all this HID functionality into its own file. You can start by taking a quick look at this. So this HID example is essentially putting up a simple report. It's just sending a simple 8-bit value, which is simulating keyboard presses. It's setting up a simple report up here. And then it's using a timer, which is a Zephyr kernel element called a K-timer. And every 2 seconds, this will send a sort of simulated update to the other side. Everything is set up down here. And then in order to see the code that I've actually made, I will have to add the project from my Git repository. So instead of HID, I've called this remote USB dongle. So this is a way that you can, if you already have an existing example, rather than make a new one, you can just add that folder directly. So you'll see that come up here as C remote dongle. Again, I have to add my build configuration in order to be able to run the code. As soon as the sort of project configuration phase of the build is ready, I should be able to access the files. So now we'll see that my file view is coming up here. So the work I've sort of done here is that I have integrated this more with the example. You should be able to see my example show up here in the files as well. I now have my main file. And then I have made all the USB HID functionality. I put it into a separate module, which I call app USB HID. And it's essentially exactly the same functionality that you saw from the previous example. It's only that now I made it into a separate module. And then I have a very simple API in a header file. I simply call this function here from main, and that sets up everything. But otherwise, the functionality is the same. So then I'll go to the next step, which is step 4. And now if I take a look at my app USB HID C, you can see that I've made quite a lot of changes. I've now added quite a lot of additional information to the report descriptor to facilitate more complex commands. So I have a report for keyboard presses. This is a quite standard keyboard report, which allows you to send 6 keys at the same time. And it also contains flag fields, which allow you to set shift, control, alt, and these kind of things. I'm using 2 different reports, which is a way to send different commands over the same endpoint with USB. So this would be report ID 1, which is the keyboard, and then on report ID 2, I'm setting up for sending consumer control commands. So consumer control commands allow you to send things such as volume up and down commands, play, pause, mute, and these kind of things, which is very useful if you want to make a sort of flexible remote control. You might want to have access to this as well. Obviously, if you want to look further into this, then you sort of have to take a look at the HID specification and these HID usage tables, which is where I'm found all these hexadecimal values that I'm setting up here. So all of these values and all these definitions here are based on the HID specification. Then I've also made a more complex structure for storing the report. So the way I do this is you need to send the report ID first by the HID specification. Then I have a union where I can either send a keyboard report, which has flags and keys, or I can send a consumer control report, which has various bit fields. Then the next step I want to do is that instead of using a timer for sending HID packets, I want to replace this with a thread, which is a more flexible way of doing it. So I'll simply load my next step. Now I can see that I'm setting up a thread down here. Zephyr or Nrf Connect Sdk is based on Zephyr, which is a real-time operating system. And one of the flexibility or one of the advantages of that is that you can set up separate threads to handle different types of functionality. It's also very easy to do. With just this simple line here, I set up my thread. I say that this function is going to be used to run the thread functionalities. I set up a stack size, some priorities, other parameters I can provide if I want. And then whenever the application starts, it will automatically run this function as a thread. And that's why in this function, I can have an infinite while loop, similar to what you usually find in main in most applications. I can have sort of blocking sleep calls. And because it is a thread, it will be running in parallel with other things in the system. And right now, I'm just copying the functionality from the original USB HID example, which was to send a dummy report every 2 seconds. The only difference is that I'm doing this from a thread instead of doing it from a timer. But later on, I will extend upon this to add more functionality. And I'll go to step 6. In step 6, I'm preparing for the next sort of complexity to come in by adding a message queue to my example. So a message queue is a Zephyr kernel feature that allows you to store different messages in a queue, obviously. And the advantage of doing that is that if you have an interrupt generating various commands or messages, you're not able to call, it's sort of limited what functions you can call from an interrupt. So a much better way to do that is to update the message queue from the interrupt handler, and then you can pull those messages from a thread context. And that's basically what I'm doing here, that whenever you want to send a keyboard packet or whenever you want to send a consumer control packet, it's putting a new message into a queue, which is simply a report, which is to be sent over HID. And then in my thread, I've updated my thread. Instead of just sending dummy packets on a timer, it will now pull the queue. Since this is a thread, it will actually just hang here forever and wait for something new to happen in the queue. And then as soon as this function returns, it means that something was put into the queue and that packet will be sent using this send report function, and it will be sent over HID. And I guess if I try to flash this code now, we might see some functionalities, but I think I'll wait until I've added a bit more before doing that. The next step is step 7, and that this step is basically adding button input to the dongle project for debugging purposes. So to do that, I'll just briefly show how we can add some new modules into an example or into a project in VS Code. So one way to do that is to manually edit the project files. So there's this project configuration file where you can manually add new configurations. There is autocomplete, so when you start adding, like when you start typing things out, you will get suggestions for things that you can change. But if you prefer a more graphical approach, you can also use this kconfig configuration tool. So in this case, I want to enable buttons. And one way you can enable buttons is by enabling this button and LED library for Nordic DKs. By using the kconfig tool, I can quite easily search for configurations. If I click this information tab, I can get a bit more information about that configuration. And if I enable it, I can also see that there are other sub-configurations within that can be changed. I think I'm going to set this to 20 just for demonstration purposes. And then you can either save that to your build files. The problem of this is that if you ever do a clean build or you want to push it to a repository, then those changes will be lost. But you can also choose save to file. And this is very useful because now it writes those changes into the project configuration file, which is as a part of a Git repository and will be sort of version controlled and retained later on. So in this case, I want to do build to embed these changes. Whenever you make a change to the project file or the CMake file or something like this, it will initiate the full build, which is quite a bit slower than just doing an incremental build where you change the source code. But once this is ready, it will automatically pull in all the files and all the modules needed by that library. So it makes it very easy to add new libraries and functionalities into the code. Now that I've done this, I can basically add some code in here to use that library. And since I'm already running low on time, I think I'll just automate that by loading my next step. So let's see here. Okay, I think one thing that's very important to note when you're working here is that sometimes you might select the wrong application, which is what is giving me trouble right now. So it's quite important to note that you have to make sure that the example you think is selected is actually selected up here. So now that I have my right example, I can see the changes that I've done with the DK button library. In this case, I initialized the library with a couple of lines down here. And then when you initialize it, you have to provide a callback. And this is a callback function. I'll just call it app button handler. It will give me a button state masks and has changed. Every bit set in button state tells you what the state of that button is, and every bit in the has changed mask tells you if that particular button changed or not. And in this case, all I'm doing is that I'm checking for these different buttons, and then I'm sending either a consume control packet, which is volume up and down in this case, or I'm sending some packets using the keyboard descriptor. And if I now try to build this and I flash it to the kit, then hopefully we can see that I can send some of these commands from the board. For some reason I can't find my connected devices. I'll try it again, just make sure it's linked to the right board. Okay, that seems to work. So now the board is connected. I'll connect my second USB cable for the USB of the Nordic device. Now you can see in the log that the device is configured. And if I now press button 3, yeah, I'll see this. You can see here in the code, button 3 corresponds to a sort of rolling counter. It starts with the A key, and then it increments for every press, so that I get this continuous alphabet coming out every time I press the button. And then I think we're running a bit low on time. I think I'll have to skip ahead a bit in my steps here. So the next functionality I want to add is to add in all this the Uart central functionality. So basically what I've done in this case is simply to look at the central Uart example. I've taken all the functionality of that example, and I've added it into a separate file, similar to what I did with the HID functionality. So if you look at my folders on the left, you can see that I now have this apply nus client handler function here. And this is basically just copied verbatim all the code from the central Uart example. The only main change I've done is that I've made what used to be a main function, I've made this into a init function. So now I can initialize this functionality from my main application. It will set up the Bluetooth stack. It will start scanning for devices, and it will also allow connecting to devices and exchanging data. Another important difference I've done is that I've replaced the default Nordic Uart service UID with one I created myself. It's actually possible to go online and quite easily, let's see if I can find the link here. There's something called online UID generator. You just create a random UID. And because this number is so large, even if you use a random number, the chance of having a conflict with someone else is virtually 0. So that's what I've done. I've just generated a random number, and I've added this into my code here to make sure that I will not automatically connect to anyone running the standard peripheral Uart example in the vicinity, but just to my own device, basically. So now that I've built the code, I'll try to flash it. And we should hopefully see on the log here that the Bluetooth stack will be running as well. Yeah, so you can see on the top of the logging here, you can see various Bluetooth initializations. Scanning successfully started means that the kit is now scanning, and also the USB HID functionality is working as well. Then I'll briefly run to step 10. In step 10, I've basically added the remote example. And the remote example is essentially just a copy of the peripheral Uart example with very few changes. So now I'll add that as well, using similar functionality that I did before. I'll have to add a build configuration for this. I'm using a 52840 DK, just like before. And while I'm building, I will also be flashing this kit. I think I have a terminal for that as well. I don't know how much you can see of these terminal logs here, but essentially I have both the remote and the dongle connected over different terminals. Then I'll make sure that remote is connected to the right kit. I'll just do that again. So that's connected to the remote board. and I will flash it. I should expect to see some kind of startup message in the log here. Yeah, there we have started the Uart service example. If you see on the log on the dongle side, you'll see that it now connected to it. And now I want to see if I can actually have communication between these two. And this is still a bit early in my example, so I don't really know if the communication is going well. So I'm going to check this by trying to debug the remote USB dongle project. And there are basically two options to debug. In this case, we have the regular debug, which is just using GDB directly from the VS Code interface. And then there's this debug with Ozone option as well. So I think I'm going to start by trying to just debug directly in the VS Code interface. I'm getting this warning here because I haven't enabled, there is a debug sort of optimization option you can select when you set up your project, but it should be able to do some basic debugging even if you don't have that set. So basically what I want to check is if I receive any data from the remote. And I know that when that happens, this BLE data received callback should be triggered, but as you can see, it's not really doing anything, so I wouldn't see this at the moment. I'll just try to set a breakpoint here. Then I'll try to start my session and play. Okay, it seems there was another breakpoint as well. So now I've started the code. You can see that everything is good. The way that the peripheral Uart example works is that I have to type something here, like hello, enter, and then we can see the breakpoint trigger. You can sort of hover over the data. You can see at least that the age is there, the length is there. It's 6 bytes. We can also see the various local variables up here. Unfortunately, this is a pointer, so I only see the first byte. One way to sort of handle that is to show this Cortex debug view memory option. In VS Code, if you press F1, you get this command window, which is really useful to trigger various commands. In this case, I can view memory. I have to write my memory address, which I can see in the variable view on the left. And I want 20 bytes. And then I can see that my hello message was received successfully over here, which was sent from the remote. Then I briefly try to see if I can also get the Ozone debugger running. So Ozone is a quite powerful debugger made by Seger. So if you're doing sort of more sophisticated debugging, this is a quite useful tool to use. And we should be able to do the same test here. I'll just go into my, or should I go into the NUS client implementation, set a breakpoint, and try to run the code. So you can see on the log side that the log seems to be okay. Try to write Ozone and enter. You see that it stopped here. In Ozone, you have a full call stack over here, which is quite useful. If you really want to see what's happening with all the BLE layers and everything else, you can see where all the callbacks are coming from. And of course, you can check the data. Ozone is a bit more clever. It understands that this is a string, so it's printing Ozone down there, which is what I sent from the remote side. And the length you can check as well. So there's some different options you have for debugging. Then I think I'll just run more or less to the final project since time is running short. And I will close this memory window here. We don't need that anymore. So now the projects are updated. I'll do a quick build of both of them and try to take a look at some of the code. If you can't see the build output anymore, you have to select the terminal and you have to select Nrf Connect over here. Then you should be able to see the build output. I'll select my remote code and try to build that as well, in order to make sure that both the remote and the dongle is using the latest step in the process. And while that builds, I'll try to take a look at the code. If we take a look at the main file of the dongle project, I've basically now updated it to have this data handler whenever there's data received. What data I'm sending is I'm sending 0, 1, 2, 3. That's the number of the button, which is stored in the first byte. And then the second byte tells me whether or not that button was pressed or released. And then based on that, I'm calling these USB HID functions. So whenever data is received from the remote device, I will send various packets. And if you want to change the remote, that signal that you send, you can easily do it just by changing the code here. And I happen to know that Zoom is using a different shortcut than Teams, which so I'll just try to change this to Alt-A and see if I can get it to work in Zoom. And I'll build it again. Then I'm just flashing my dongle code. You should see the dongle update here. Once that's done, and then I will select my remote and flash that as well. And now I should see that whenever I click a button on the remote side, then I should be able to receive some text here. So just see, I don't know if you can see my board at all. This is the remote board. And then I should be clicking button 3. Yeah, and now it's basically going from the remote to the dongle board and then over USB HID. And let's see if the muting is working as well. I guess I have to. I guess I got the wrong shortcut for mute. Must have been something else. And then finally, as a little extra functionality, I also integrated a button module from the Nrf repository, which is called the Core Application Framework. And this is something I will also be pushing on the repo, so you can check it out later. But this makes it very easy to integrate different buttons and different configurations. So I'll see if I can get this to work right now. So on my side, I had this game stick laying around, which I used for some different personal project long time ago. Now this should be connected to my dongle instead of the DK I was using earlier. And yeah, just by flipping the switches here, I'm now able to send commands to the dongle. And this one has a lot of buttons. It has, I think, 12 or 16 buttons in total. So obviously using this to control Teams or send shortcuts is maybe not very useful, but if you want to make a game controller, this is obviously nice to be able to integrate with the code quite easily. And I think I'm more or less out of time, so I think I will leave it there and we'll try to take some questions.
Awesome. Well, thank you so much. That was really fun to watch. Bjorn has been doing a great job answering a ton of questions that we've already had, and we have a lot more coming in. So if you do have questions, if you haven't asked them yet, now's your chance. Ask them in the Q&A, and Bjorn and Torbjorn will try to answer as many as possible in the next 5 minutes or so.
Sounds good.
Do you want to start, Torbjorn?
Yeah. Do you know which questions are on the top of the list?
Yeah, well, there was a good one actually. I wasn't quite sure. Let's see. Yeah, are there any differences between Nrf5 SDKs and Nrf Connect Sdk based on power consumption? I think there were some other questions. You know how Zephyr, a real-time operating system, influences power consumption?
Yeah. I can try. I don't know how much benchmarking we've done on that, to be honest, but obviously the Zephyr RTOS is designed for very low power consumption. And I know we have worked a lot to make sure that the libraries we provide are optimized. But I think we just have to measure it. I mean, we have the PPK, the power profiling tool. We could probably do some measurements on our side, and I guess we can take a look if we've done any of that already. I don't know what's available there, to be honest. But I would expect the difference to be quite small. I mean, the main contributor in the end is going to be the sleep current of the device and what kind of peripherals you enable. So if the use case is similar, then the power consumption should be very similar as well. In terms of processing speed and these kind of things, it's more or less the same between the two.
And I guess also the radio influences a bit, like you said, the sleep current, how much you're using the radio, etc.
Yeah, and that's, I mean, if you're sending a Bluetooth packet in Zephyr versus Nrf Sdk, it's going to be the same time and everything else, so that shouldn't be a big difference there. Especially with Bluetooth, we have this Bluetooth software controller, which is similar to the Bluetooth stack in the Nrf Sdk, the soft device that many people know and love. And if you use the software controller in Nrf Connect Sdk, then you're basically using the same link layer and the controller underneath. So it should be very similar from the Bluetooth point of view.
Yeah, and I think we also got a quick question, I think it was before, about machine learning, or what was it called, AIoT. So we do have a partnership with Edge Impulse. I can actually maybe just put it in the chat. Let me see if I can send it to everyone there. So here you can see these. So we have a getting started guide for both the Thingy 91 and Nrf 9160 DK. And I don't remember the numbers there, but even just running machine learning, I wonder if it was like 2 microamps. I don't know if that's right. But so compared to running machine learning versus sending information via the LT and using the radio and sending it to a cloud and doing processing on the cloud, it can be a lot more power efficient to just do a lot of processing on the device itself instead of using the radio a lot. So yeah, that's just good to note.
Sorry guys, I'm just disabling the alarm here so I don't get kicked out.
Okay, I'll take another question then while he's while Torbjörn's doing that. Let's see.
Well, I saw a good one.
Yep.
Which tools would you recommend for creating a HID descriptor? And to be honest, I'm looking for an answer to that myself. I think I found this Descriptor tool, which is some old tool that allows you to at least get some help creating the HID descriptor. But to be honest, I haven't seen a really nice tool for doing this. And I usually resort to doing what I did in the workthrough, just copying an old example if I can find one and make minimal changes based on that.
Oh, there was also another question, Torbjörn, about why we need the dongle versus just using the Bluetooth host or the Bluetooth stack on Windows PCs.
Okay, yeah, well, I guess the Windows support is quite poor. I don't know how, I don't think we've done a lot of work with the native Windows support. And I guess another problem is that then if you do a lot of work on that, that won't work on other platforms. So in our case, I just use the dongle for simplicity, basically, because USB HID, that works on everything. That works on Linux, Windows, Mac. There's really no surprises there because it's an old and established technology. But doing something on Windows, then it would be very much Windows specific and wouldn't be such an easily portable solution. And also, it's also made for a good demo to show how to integrate multiple examples into one. So in this case, it's a bit about making a good demo as well, not just making an optimized product. But as I write in the README, I would like to have a separate branch of this project that does Bluetooth HID directly. So you can just communicate directly with hosts that support Bluetooth HID, which includes most Windows devices and yeah, mobile phones as well. So that should definitely be possible. You basically have to start out with one of the Bluetooth HID examples in Nrf Connect Sdk instead of using the USB HID and Uart examples that I used.
Awesome. We are at the top of our hour, but maybe we can choose one more question to answer before we sign off.
Yeah.
I have one.
Go ahead, Debian.
Is it possible to use the Nrf52A40 dongle to capture Bluetooth 5, Zigbee, etc. traffic and analyze the received packets?
Yeah, so we have a sniffer solution, or you wanted to present that, Debian?
I forgot the name, so you can
yeah. Yeah, so we have this Nrf Sniffer, which allows you to sniff Bluetooth packets. It doesn't support all Bluetooth 5 features, but it supports like 2 megabit PHY, and I think it supports extended advertising. But there are some Bluetooth 5 features that are not supported. But in general, it's a very useful tool because you get it for free if you have a Nordic DK or a dongle. You don't have to buy one of these expensive professional Bluetooth analyzers. And it gives you a lot of debugging capability if you're working on Bluetooth applications. We also have, I think there's a thread sniffer. I'm not sure about Zigbee if we have a sniffer for that. I would have to check.
Awesome. Well, thank you both so much for joining for this demo, for your presentation. And thank you everyone else for joining us today. This has been a lot of fun. I hope you have a great rest of your day, and we hope to see you at the next one.
Thank you.
Take care, guys.
Bye.
Bye-bye.